Welcome again, folks, to our channel of mathematics. You are with La Geometry, giving you free marks and making sure that mathematics is easy as a pie. Now, today, I am doing proving trigonometric identities, which goes back to grade 11. But now, in grade 11, remember that you only dealt with trigonometric identities that mostly had quotient identity, tan, and square identity, sine squared theta plus cos squared theta, which is 1. Now, in grade 12, we added compound angle identities and double angle identities. Now, in most cases, people normally say to me, but tell me, how do you know what to substitute cos 2x with? And I always say to them, because the given mathematical problem tells me what to do. I'm going to show you that. Remember, double angle identities, we know that sine 2 theta implies, or it is equals to 2 sine theta cos theta. Meaning that when you see sine 2 theta, you actually see 2 sine theta cos theta. When you see 2 sine theta cos theta, it's exactly the same as sine 2 theta. Now, secondly, cos 2 theta. When you see cos 2 theta, it is equals to cos squared theta minus sine squared theta. Or it is also equals to 2 cos squared theta minus 1. Or it is also equals to 1 minus 2 sine squared theta. Now, I want to focus on these ones and tell you why you have to substitute this with that. First of all, in some problems, we will give you the angle or require the answer of the angle to be expressed as theta. Now, if you get a double angle identity, you have to write that double angle identity as theta. Cos 2 theta, you either write cos 2 theta as cos and sine of the angle theta. Sometimes it would only be necessary to write cos 2 theta as cos theta only. Sometimes in some problems, cos 2 theta must be expressed as sine theta. Now, like I said to you, the problem talks to me. It says to me, you have to substitute either this or that one. Let's take this example. Prove that sine x plus sine 2x divided by 1 plus cos x plus cos 2x is exactly the same as tan x. Now, in an identity like this, I have identified that as a double angle identity. I have also identified that as a double angle identity. But now, my answer is supposed to be in terms of x, not 2x. And for that matter, I've got x and x there. That is why I'm going to express these in terms of x, sine 2x in terms of x, cos 2x in terms of x. Now, let me prove the identity. When you prove the identity, don't forget that you choose the side that you can simplify the most, not your teacher or anyone, you. Now, in this case, I'm looking at this and I'm seeing the left-hand side as the side that I can simplify the most. And my left-hand side is sine x plus sine 2x divided by 1 plus cos x plus cos 2x. That is the sign that I can simplify the most. Now, how do I simplify this? First step, I know that tan x is actually sine x divided by cos x. Let's do that there. This is actually sine x divided by cos x. Meaning that in my answer, my final answer, I want to have the numerator as sine x. Now, I am fortunate that this is sine x, this is also sine. I'm going to make sure that I maintain sine in the numerator. Let's see. Sine x plus. Now I know that it means 2 sine x cos x. That is 2 sine x cos x. And remember, in your information sheet, it would be provided. These would be there. Now we go to the denominator. Looking at the denominator, I've got 1 plus cos x plus cos 2x. I must write cos 2x in terms of x now. Remember that my denominator must be cos. Now, let's come to these. Do you realize that I only want cos, not any other thing as the denominator? If I can choose cos squared theta minus sine squared theta, I have now invited something that I don't want in the denominator. I'm not saying it is wrong, but I'm saying if I choose this, I shall have invited something that I don't want in the denominator. I must keep my denominator as cos throughout if I can. Now you look at this one. It is 2 cos squared theta minus 1. Now, if I take this one, I would be having cos and I would be having cos there. But if you look at this one, it is 1 minus 2 sine squared theta. Now, if I choose to substitute this with this one now, I will be having cos and sine. And of course, I said I only want cos. Now, it means the right choice for this is this one. Now, let's write it down. 1 plus cos x plus 2 cos squared x minus 1. Now, I have expressed all angles in terms of x. You can see that is x, you can see that is x. Now from this, what do I do? My mathematics follows. I've got sine x plus 2 sine x multiplied by cos x. That can only mean factorizing by removing the highest common factor. And in this case, the highest common factor is sine x and sine x. Now I'm removing sine x as my highest common factor. Then if I do that here, I'll be left with 1 plus, I have removed that there, I would be left with 2 cos x, close bracket. What is happening now? In the numerator, I'm multiplying this by that bracket. Denominator, there's a 1 there, there's a 1 there. But this one is positive, this one is negative. I'm talking like terms now. 1 minus 1 is a 0. I'm now left with, in the denominator, cos x plus 2 cos squared x. Again here, I can factorize by removing the highest common factor. My highest common factor is cos x. And of course, I'm left with 1 plus 2 cos x. I close the bracket. Now, looking at this, I am multiplying, dividing and multiplying. It says now I can cancel the same. That whole bracket there cancels the whole bracket. And my answer is sin x divided by cos x. And we know from the quotient identity tan theta that it is the same as sin theta divided by cos theta, meaning that this is exactly the same as tan x. Now what can we see here? This side simplified is exactly the same as the right hand side. I must therefore conclude and say, therefore, left hand side is exactly the same as the right hand side. Now, folks, be very careful here. When you deal with the double angle identity of cos 2x, look at what you want as an output and come to your 3 choices. Choose wisely. Thank you very much.